Morning geometry. So today starts our chapter 12 on polyhedrons and three-dimensional figures. So if you look at this, we're just going to talk about what polyhedrons are. It's just a many-sided figure with many different faces and edges. So we talked about polygons, right, that are two-dimensional. Polyhedrons are three-dimensional figures. So you can see some different types of polyhedrons here: a tetrahedron, a cube, an octahedron, a dodecahedron, and an isosahedron. So these figures are named based on their faces. So I'm going to use my highlighter here and just talk about what these are. And I really just want to highlight. So vertices are when two edges meet. So if I look at my dodecahedron here, I'm highlighting my vertices in green. Sometimes you can think about them as the angle, right? But in this case, it's part of a three-dimensional figure. Let's look at edges. Edges here are when two faces meet. So here, if I highlight it on my cube, it looks like a line, right? So when two faces meet, it forms a line, like in this cube or this octahedron here. And then faces, get my orange, faces are the plane that make the shape. So here, this very front one here, this face is a triangle, right? So these figures are named based off of their face shape, first of all, and then the number of faces they have. So let's think about this. A tetrahedron is 1, 2, 3, 4, it has 4 faces. Let me get my pen out. 4 faces. See how many edges it has. 1, 2, 3, 4, 5, 6 edges. And vertices, 1, 2, 3, 4 vertices, right? So there's your tetrahedron. Cube, this is the one that we're going to be mainly working with. Vertices, 1, 2, 3, 4, 5, 6, 7, 8. Edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then faces here, we have 1, 2, 3, 4, 5, and 6 faces. So today we're going to be talking about finding surface area of some of these figures. We're going to be first talking about, how do I get this up? I want to get you all. There we go. We're going to be talking about cubes here a lot and rectangular prisms. So I'll show you a little bit about what these are. Change my, so I can prove what we just talked about. Here's my cube, right? And this is called a net. When I unfold all of my sides, so you can see here, let me zoom out a little bit, that we have, thinking about all of our edges and our faces, 1, 2, 3, 4, 5, 6 faces, right? So we're going to be talking about surface area and finding the surface area of prisms, really, and we'll talk about prisms in a jiffy, in a second. So we're going to move on to our next notes page. Let me pause this and get that ready for us. All right. So I'm going to be using this note page as we go through, but I'm not going to do all the notes in here. So I'm going to be using my math journal. So if you don't have your math journal out, go ahead and get it out. We're going to be looking, we've talked about polyhedrons, and now we're just going to move into surface area. So here we go. I'm going to be looking here. We're not talking about cylinders today. We're going to be talking just about prisms, right? So let's talk about what a prism is. A prism is a 3D figure with bases that are the same. That are the same shape, right? So let's look at a couple of different ones, and I'll tell you how we're going to name those, right? So let me stop sharing this, figure out how to do that. All right, so let's look at this one. Here's a prism here. This is a triangular prism, and we know that because the base, top and bottom, is a triangle. So this is called a triangular prism, and if you notice all the side faces, these are your lateral faces. These are all rectangles. So this is called a triangular prism based on the shape of the base. Let's look at this one. We talked about this one already. This is a cube or just a rectangular prism or a square prism. You can call it either one. When we have a square prism, we call it a cube because all of the faces could be considered bases, right? Because they're all the same. So this is a cube. Here's another one. Let's look at that base shape. This base shape, remember from our polygons, is a pentagon. So because the pentagon is the top and the bottom, that's the base. And so we name it by the base. So this is called a pentagonal prism. Notice how the lateral faces, that means the side faces, are still rectangles. All right, let's look at this one. This is a rectangular prism. So if you notice, the bottom is a rectangle, right? Or we can call it a square. And then the sides are also rectangles, which is kind of funny and kind of hard, but this is a rectangular prism. Then we'll look at this one. Whoops, my bottom fell out, my top fell out. All right, so my base is here, top and bottom. The shape here is a hexagon, 6 sides. So we call this a hexagonal prism. So those are just a few of our prisms that we are naming, but really we're going to be looking mostly at rectangular prisms here and how to find the surface area. So let's go back to our notes. Make sure I share this time. So finding surface area. So we have 2 different types of area that we're going to be finding. We're going to be finding the lateral area, and we're going to be finding the surface area. So the lateral area is the area of all the lateral faces. So think about this. I know it's terrible to put the word into the definition, but think about painting walls. Not the ceiling or the floor, right? So that's lateral surface area. So if I were to find the surface area of this prism, it would just be around the edges, not the bases. Painting walls, excluding bases. Surface area is the area of the whole object. So it's lateral area plus, plus the area of the bases. There are easy formulas to do this. So let's talk about lateral area. Finding your lateral area is the perimeter of your base times your height. Super easy, right? Someone else figure that out. We could just get to use it. Isn't that nice? Your surface area is, guess what? It's your lateral area plus the area of the bases. It's the perimeter of your base times your height plus your 2 base areas. So P here is perimeter of the base. H is height of the 3D figure. And then big B is called your base area. I'm going to put this in a cloud because this is super important, okay? Super. All right, so let's see what we can do. Let's just name this right now. So I'm going to draw our little rectangular prism here. Not too shabby. All right. So perimeter of the base is all the way around. Added up all the sides, right? That's the P. Let's name this too. Here's the height. It's the height of the figure. That's the H, right? And then let's think about area. Base area is this yellow part, right? That's your big base area, if you can't see that. So think big B doesn't mean just base length or whatever. Big B means base area, okay? So that's your quick help for those. Let's do a couple of examples. Just finding lateral area and surface area. So let's take an example here. If you're following along on that worksheet, it is exercise number 2. Let's do the first one, exercise number 1. So they give us I'm going to make up some numbers here because they don't give us very much. All right, this is 7.2. This is 4. And they tell us that all of our sides are the same, right? So I'm going to tell you the height here. This height here is, let me get my calculator out. All right, so let's find our lateral area and our surface area here. So our lateral area, just like we said before, is the perimeter of your base times your height. Well, we already know that our height is 7.2, so we'll plug that in. But what about the perimeter? What I know from up here is that all of my sides are the same, right? So if this is 4, this is 4, this is 4. So it's 4 times 3, that's 12. So my lateral area is 12 times 7.2. 86.4. So my lateral area is 86.4. This is nice because when I get to my surface area, it's my lateral area, or the perimeter of the base times the height, plus twice your base areas, right? So perimeter, or my base times my height, lateral area is 86.4. That's great. I don't have to do any extra work, do I? Plus twice my base area. Well, look at my base. My base is a triangle, so I'm going to draw it out here. If your base is a triangle and all these sides are 4, and the height here is 3.5, how do I find the area of that base? Well, it's just the area of a triangle, right? So it is 1/2 base times height. Remember that? So we're going to plug in what we know. 86.4 plus 2 times 1/2. My base here is 4. My height is 3.5. Let's plug that into the calculator, see what we get. We get 4 times 3.5 is 14. Take half of that, 7, and then multiply it by 2, and we get 14 again. So we have 86.4 plus 14 equals my surface area. Let's add that to 86.4, and we get 100.4. Now we can think about reasonableness, right? Is it reasonable for my surface area to be larger than my lateral area? Well, yes, of course, because my lateral area is only the area of the sides around it, right? And my surface area is the sides around it plus the top and the bottom. All right, let's do one more. I'm going to be mostly working with rectangular prisms, so let's do one of those. This is number 2 in your notes page, if you're looking along with the exercises. If you are not a geometric shape enthusiast, you don't have to draw these, but it does help. All right, so lateral area is perimeter of my base times my height. So perimeter of my base here, this is 12, this is 6. I know this is 12 and this is 6. So I'm going to add all those together, right? Perimeter is just adding all the sides. 12, 12, 6, 6 times my height, which here is 3, because we're looking at the height of the figure, right? 12 plus 12 is 24, plus 12 more is 36, times 3, 108. So my lateral area is 108. Now let's plug that back in and find surface area. So surface area is my lateral area plus twice the bases, right? So in this case, my lateral area is 108. And then if I want to find base area, let's think about that base there. What figure that base is? Well, it's just a rectangle, right? Where one side is 12 and the other side is 6. So if I want to find the area of a rectangle, it's just length times width, 12 times 6. So let's plug this in and see what we get. 12 times 6 times 2, 144. Why do we multiply it by 2? Because there's 2 of them, right? One on the top, one on the bottom. Let's add that to 108. It's 252. All right, so these two, lateral area and surface area, apply to all prisms, right? All prisms. All right, so we have some practice to do, and I'll see you in class.